So here's another example. If we look at this one, because the right hand side is 0, I always look to see if I can simplify it, and 4s goes into all of those, 4 and 8 and 4, so I can actually simplify this right down to, well actually first of all let's form the auxiliary, 4m squared plus 8m plus 4 equals 0. Dividing through by 4, m squared plus 2m plus 2 equals 0. Sorry, plus 1 equals 0, dividing through by 4. And now we can try and solve this one. We're going to try and solve this one. Last week we looked at perfect squares. Is this an example of a perfect square? It is. So it's an example where if we use the quadratic formula, and we'll go through this, but it's worth looking for it to save yourself a bit of time. If you can see it's a quadratic, a perfect square rather, you can almost miss out this next step. But let's have a look at it anyway. So let's use the quadratic formula. A equals 1, B equals 2, and C equals 1. And solve this quadratic equation. So m equals minus b plus or minus square root b squared minus 4ac. You'll remember it eventually, all over 2a. And then put in the numbers. So minus 2 square root 2 squared minus 4 times 1 times 1 all over 2. Square root of, well, 0. So if it's a perfect square and we put these numbers into a quadratic formula, we actually get a situation where the root is 0. So that's what the perfect square is telling us. And effectively, m equals just minus 2 over 2, which is minus 1. One root, one solution. So this is a different type. If we recognise that that was a perfect square, what we've talked about before, if we recognise that this is a perfect square, and we remember that that means we can write this as m plus half of whatever the coefficient of m is, because that's the perfect square, isn't it? We could have jumped straight to here. And then we can say square root both sides, m plus 1 equals 0, and n equals minus 1. So in other words, you can get to that solution much more quickly if you recognise it's a perfect square. However, I wanted to point out that even if you don't, you go through the quadratic formula, it will come out because the square root will be 0, and then you'll see it then, okay? So the point is we now have a situation where we've now just got one solution, m equals minus 1. So we can write our general solution now. We go back to our table here, and this is the second case, real and the same. One root, in other words, k. And that's the case where the square root is 0. So if you want to add that to your little table here, it's real and different if the square root is positive. It's real and the same if the square root is 0. Leaving us one more example to look at in a second where the square root is negative. So now we can write down our general solution. It's of this form. Y equals ax plus b e to the kx. So we can go back to our example and write down that general solution. So y equals, well in this case, what is our yes, it is y and x this time, so y equals ax plus b e to the kx. That's our form, that's our general solution. So for this example, y equals ax plus b e to the minus x, because k is minus 1. And that's our general solution. Now we've got to work out what the constants a and b are.